So key sending. It's also called, used to be called Sphinx sending, which was killed. That's a dead name now. And then also maybe, yeah, called spontaneous payments. Um, okay, so the general idea is right now we have a system where I generate a payment request. It includes a payment hash, R hash, and then I give it to you, and then you set up the route and pay to me, and that's how payments complete on Lightning Network today. But it has a limitation where I have to always be generating these R hashes and giving them over to you in these invoices. If it doesn't really match what the Bitcoin experience is, where I just pay to an address and then that's it. Like I can just pay to this address. I don't need you to create new um, payment requests. So this was left out of Lightning in the initial version for plenty of good reasons. But there's also really cool things that you could do if we did have this key send. So I could just talk about lots and lots of different use cases. If you want to do donations, you just choose your own amount and send it off there. We already have kind of that in the wild with this tipping sites. You can do something like pay people. Like I have this problem on y'all's where if I want to pay somebody for writing a great article, well, I have to wait for them to come to me and make a payment request, and then I can send it to them. But wouldn't it be cool if I could just like push it to them? So another interesting thing about key sending is if we can include the amount that the person is going to get in the onion packet, we could include information like a message. So here's something I want you to do. So I could say, here's $1. Please send a postcard to my mom, and that could actually be like encoded into the actual payment. So you could have kind of like Lightning only APIs. It could be helpful for AMP as well. So I was just talking about like you're going to need this coordination step where I'm going to kind of have to tell you, hey, this payment is coming through, but also there's another payment coming that has the rest of the money. And if we're getting into like sharding the payments, sharding the pre-image, I kind of have to like negotiate that with you of like, oh, how many shards are there going to be? Like, how much should I have to wait for? And like, how are we going to put this data together? So keysend could be helpful for like arranging that because you can send these messages. Another amazing use of keysend would be if you could just like deposit to your exchange. And because you could include this message in there, you could include like your user ID at the exchange. You could say like, I'm user XYZ, and here's $500. Add it to my account at my exchange. We have this idea of the streaming data use case, which hasn't really been realized outside of like hacking stuff, but maybe this could make it easier by saying like, as long as I've received payments from you, I'm going to let you continue watching this video stream or something. Then some other interesting uses of this could be that to deal with just random incentive problems. So maybe so this incentives and probing kind of go together. So we have kind of an overlaying incentive issue on the network where there's only one thing you really get paid for in Lightning, which is you route a payment successfully. But there's lots of different things that you do that you don't get paid for, but still require you to do some work. So like a failed payment, you don't get paid for that, but you still had to like change your commitment transaction and deal with networking and stuff. So one possible use of keysend is to like just incentivize it directly, to just say like, here's some money, I know I've been like utilizing a lot of your resources, and that could tie in with a future layer of anti-denial of service that nodes could enforce. So nodes could start saying like, well, if 100,000 requests came in and they were all failures, I'm going to start throttling you like until a new successful thing comes in. So you could kind of like pre-attach a payment to say like, I'm gonna, there's some money. Here's some money. Please reduce the throttling of this channel so that I can continue to try it. Okay, so these slides are also pretty short, but and I mentioned this the other day, but here's kind of like an illustration of an alternative to keysend, which is this idea where you can overload fees. So if I want to pay somebody today, and I don't want them to generate an invoice, there's a technique called invoiceless payments where you overload the fees. So you can see in this diagram that I'm A, and I want to give C 21 satoshis. So I set up a circular payment route. I go from A to B, B to C, etc., all the way back to myself. And then on this route, I actually like overpay the fees because let's assume everybody's just charging 1 satoshi. But from C to route through C, I like say, oh, guess what? Here's a bonus fee, extra money for you. So this is kind of like a fun way to just play around and like give some people some extra satoshis. And you can do it now. There's like a plugin for C Lightning and stuff. But anybody remember what the problem was that I said before? Not you guys.
If the payment goes through E, they get the pre-image.
Okay, so the payment goes through E, and what happens?
Yeah, they know it's, how does that work? It's like if just the fact that if they see the pre-image and it hasn't gone through C, and they know that they have a route in A, then they could take the full amount. If it's relevant. So I see that's the fixed routing though. But to get from A to C could go through E, right?
Yeah, so it has to go through E because that's how it doesn't have to, but that's how the route was constructed. So,
but if I think what you're saying is like if B or E were the same, they can short circuit them.
Yeah.
Okay, yeah, for sure. If B and E are the same person, what they can do, or they're just sharing information, like B can say, oh, I've got this incoming HTLC for 25 satoshis, and they can just have E say, oh, I need to send this. This guy is expecting like 1 satoshi, right? So E can lock this one satoshi payment into place, and then A doesn't really know what's happening on the other side of once it gets past B. So E locks the 1 satoshi invoice to A. A reveals the pre-image, and now B can use that pre-image to take the 25, and now C and D were cut out, so they didn't get anything. So that's kind of a problem with Circle Pay that would be solved with the Sphinx sending. I just said Sphinx sending, key sending. Okay, so yeah,
One part I still don't fully understand is like proving that I paid to the merchant, right? Like,
well, in this case, the merchant is you, right? So like you generated that pre-image, right. So it's a circular payment.
So I can't really prove anything.
Right. I mean, if you could, it would like be a logical inconsistency because it didn't happen. Yeah. Okay. Okay, this is another interesting scenario. So let's talk about like how tip-and-dummy works. Not to call them out, but like what exactly is happening. So let's say like I get an invoice for 0 satoshis, and like D has generated this invoice for 0 satoshis, and we see this in the wild today. So I am like, oh, well, I want to actually pay 18 satoshis because I like that tweet. So I set up a route. I'm A. I set up a route and I pay 20 to B, and then there's a 1 satoshi routing fee, and then at the end of my route, D, which is the tipping site, gets this 18 HTLC locked to it. What's the problem with this scenario?
steal the amount, but I don't remember why.
Okay, yeah. Why? Why can that's true. Somebody can steal the amount, but why can they steal the amount?
If D is expected, you can pay any
You don't know
amount
how
to
much you
zero. You
So
pay
what-
any amount to zero invoice, so you don't have to give D 18.
That's exactly right. Yes. So let's say C knows that D is a tipping site that's putting out these zero invoices. So D has no idea how much to expect. They gave a zero invoice out. So they see an HTLC coming in, and they're going to accept it as long as it's greater than 0, and they're going to give the preimage out. So what C can do, C can get this 19 Satoshi HTLC locked to C, and they can say, oh well, the next hop is going to be this site tipping site. So what if I just give them a 1 Satoshi invoice? What I just lock a 1 Satoshi HTLC to them, and then the tipping site is going to say, oh, I've got this 1 Satoshi HTLC locked to me. Great, I got a tip for one Satoshi, and then it will give up the pre-image, and then C will be like, okay, I got the pre-image, and then it will take the 19 that's locked to it. So Sphinx send is a more secure way to do the same use case.
That's actually not true. We commit to the amount that D should receive in the onion.
Okay,
So we
so
are
I
telling
skipped
D
a step.
how
I
much
skipped a
to-
step.
how much
Yes,
to
yes, I
receive.
skipped a step. Sorry. Okay, and it's also a good point about how to do this workaround. So here's what I do. I don't actually literally change the amount. So I have this Sphinx. I have this onion packet, and I don't actually know where it's going to end. Even, I don't actually know that definitely tipping is like. Maybe I'm just routing through tipping. But what I can do is I can make a new payment, a totally new, brand new payment, and I know the hash, right? So I make this brand new payment that's separate from this existing ongoing payment. Then I lock it to them, and if they're not the recipient, what they're going to do is they're going to be like, I don't know about that hash. I never heard about it before. So they're going to return an error. They're going to say unknown payment hash. But if they are the recipient, they're going to be like, oh, awesome, I knew about that hash because it's going to me. So they're going to release the pre-image.
You could still do 20 zero Satoshis invoices and every time send 1 Satoshi, and then no one could steal your.
Well, actually, you could do millisatoshis. They're going to accept millisatoshis. Okay, so here's another way to solve this problem other than key sending, is that you have the hop hints. So the hop hints are a way to kind of like encode some extra information. I mean, I guess there's a couple ways that you can kind of like work around this in the current scheme. In the hop hints, you can kind of tell the sender, hey, encode this extra data to me when you're sending it to me, and the hop hints are encrypted. So the C doesn't know what the hop hints contain. So you could kind of get some extra information to D to like tell it like what to what's going on there, and then it will be harder to also fake like the payment. So remember, we have to like exit the Sphinx packet and go into a new payment, but that new payment doesn't know about that hop hints that were generated by D when it created this like special hop hint invoice. So you kind of like check the veracity of the send using those hop hints. Another way is that you could just hold on to the invoice and then have the tipper like confirm the amount. So like you could be like, here's a 0 invoice, key in your send, and then the tipping site could be like, okay, I received something for 1 Satoshi. Is that what you wanted to pay? And then you could say, no, somebody took it. Yeah, so there's different ways that you can kind of work around this problem, and probably it's not the biggest issue if you're just sending around a few Satoshis, but the keysend is a cool way to just say, let's encrypt everything so that even if D wanted to, they couldn't accept the payment. They need to decrypt the payment. So I'll get into that, like about how that construction works. So the way that keysend works is not too complicated. It's based on that the onion packet has extra hops. And there's different ways that we can construct keysend, but this is one way that you can construct it, is you can say like, every time you send a payment out, you're actually encoding like this 20 hop basket of potential hops, and those other 20, even if you're just sending 2 hops, you're still making this 20 hop packet just to like confuse people so that they can't really know like, oh, are you sending 2 hops? Are you sending 20 hops? So the rest of those hops actually leaves like a bunch of space. And what we can do is we can say when a payment gets to its real destination, we can give a little clue to the receiver, and we can say the rest of those hops actually you can just decrypt those. Those are just like padding, but we're going to like shove a bunch of extra information in there. And so it already includes the amount. That's fine, but like we can also shove in just arbitrary messages in there. And so like what you're actually doing is you're like unwrapping the rest of the layers of the payment. Of course, the most important thing that we're going to include there is the pre-image. So I'm going to generate the pre-image as a sender, and I'm going to lock it to the route using the payment hash of that, like the hash of that pre-image. And then when it gets to you, it'll have you'll decrypt it with your key, and you'll say, oh, here's a little clue that I need to unwrap the rest of the hops. That those are just fake hops, and here's a little blob of information that's a pre-image that's going to allow me to like claim this HTLC that's locked to this payment request. And this is the big advantage of doing it in this kind of like hacky way is that it will work with the existing network with no changes. Nobody really knows that we're overloading these hops with extra information. Okay, so even though keysend solves problems, it also creates some problems. So the big thing we really lose is this proof of payment concept. The pre-image being revealed is already a little bit of a weak proof. It doesn't necessarily mean anything except for the pre-image. Like we're kind of like trying to make it super strong, but it's not that strong. So it's still nice though, right? It's nice that if you pay a payment request, you get this pre-image, you put those two together, and you say I paid. So keysend doesn't have that. If somebody's like, send me $5 for this coffee, and you send them $5, and it's using keysend, they can just claim it never happened. It was not on the blockchain. So that's kind of a problem. Another issue is like, what if people are just hitting you with all these keysends at like 1 millisatoshi? That's no fun. Like, especially if we put like a message in there, which is like, hey, check out my gambling site or something. Well, you don't want to have that like spamming up your UI, or you don't want to like be filling up your disk, things like that. So you probably want to be careful if you're going to accept keysends that you had some like sane minimum limits or something like that. And of course, the normal rules of Lightning still apply. You don't really know who's the original sender, so you're just getting random payments. You can't say like, oh, I'm only going to accept payment from good people. Okay, so although you could refuse to accept with keysend, you still have the same thing that you have in normal Lightning, which is like you can say, oh, I'm going to turn away this money. Okay, another major problem with key sending is if you're using, so the ideal would be like everybody just has their mobile phones and like you have like your public key and then you scan somebody else's public key, now you can send to them. You don't need to like go and fill in the amount that you want, generate a payment request, and then the payment request is going to time out after 3 minutes. You're going to have to like keep your phone on. Like it would be cool if we could just be like, here's my public key, send me money. But one issue that we lose from payment requests is this hop hints. So people on their phones, and also merchants potentially, are creating these hop hints because they have private channels. And if you just knew their public key, it wouldn't be sufficient for routing. So like they would open up their phone, they would reveal their public key, but you wouldn't know like who are your channels and which channels have capacity and stuff. So right now we're like pushing that into the hop hints. But if you just show the pub key, it would be harder for you to figure out how to route to that person. Um, and another problem is just more things on the protocol. So we already have like lots of different things to implement for Lightning, and we have a working payment system that I generate a payment request, and you pay that payment request. It's pretty simple. It's pretty simple, but like still a bunch of things to implement. So we have to like really consider carefully like how do we want to add that? Like it would be nice if we had like a very consistent standard across all implementations about how they operate. So like if I ask the thing about Lightning is you actually don't have, there's no consensus, right? So people can go and make their own different things. So like I can make a channel that's $1 million, and that's between me and my peer. Even though in Lightning we have like this rule, it's like don't make a channel bigger than 0.16 bitcoins. It's not like a consensus rule. So as we add more and more features on different implementations, we now no longer have the standard set of expectations about how something works. So like you're going to go, maybe you could say, oh, I could put on y'all's like a feature like provide your pub key and I'm going to like send you payments. But then all the clients that didn't implement this key send, they're going to be out of luck, right? I mean, I already have this problem like because I asked for your public key, and some wallets, including Lightning Labs wallet, don't show your public key. So the more complex we make it, the harder it is to make like this, to get this standard of like, here's how Lightning works, and if you implement this feature, it's going to work on everybody's wallet.
I was thinking like if the payment hash was had like homomorphic properties, it would be possible to do a proof of payment. Like only, you can only construct a pre-image if you know a secret key.
Yeah, but although you wouldn't have the payment part, right? Like you wouldn't have the like what am I paying for? Yeah, but like the cool thing about like the Bolt 11 invoice is that it includes a description and the amount and like the timestamp of like what is actually being paid for. So you have a really like self-contained proof that you can combine with that pre-image. It's all signed. So that's just like logically incompatible with just sending money. Yeah, and if you could prearrange something, then why don't you just use a payment request?